Good morning, everybody. Can you hear me pretty good out there? Perfect. My name's Kevin Reedy. I work for a company called BellyCard, based out of Chicago, about 100 employees, 20 engineers. And today I'm going to talk to you about how we do our load balancing, specifically in an always changing dynamic infrastructure. So first I'm going to tell you about our infrastructure stack over time, starting with version 0, which I call the dark age. Then we'll go over how we use Chef to configure Nginx. After that, we'll talk about how we've kind of changed away from that and using data from something called Consul and its service discovery platform to configure Nginx. And if time permits, because I think I've got about 80 rapid-fire slides here, I have some pro tips on configuring Nginx, especially when it comes to configuration management. So even though my first slide said I'm going to talk to you about Chef and Consul, I want to kind of put out a disclaimer that nothing in this talk is specific to Chef or Consul. Chef, Puppet, Ansible, Salt, CF Engine, all of the rest of them are great products, and you should be using one of them. We enjoy Chef. I'm sure a lot of other people do too. Same way it goes with service discovery, Consul, etcd, Zookeeper. They're all great, so use what works for you. So first, what is Belly? The prettiest slide that marketing gave me, we're essentially a replacement for a punch card at a coffee shop where you buy 10 things, get one free with a digital solution. We put an iPad in the store, you scan in using your phone or actually a physical card with a QR code. We can track your points, give you rewards, and we actually build marketing tools on top of that. But I'm not here to talk to you about Belly as a company. I'm sure if you're interested in that, you can just go to our website. But I'm going to talk to you about our infrastructure stack. So version 0, back when we were 3 developers and before I worked there, it was a monolithic Ruby on Rails application, which meant that every API call, every part of our website, everything went to a single Rails app. It was backed by MySQL, MongoDB, Memcache, and we deployed it on Heroku, which is a great place to start. So version 1, A New Hope, we decided Heroku wasn't going to meet our needs anymore, so we started deploying something called Capistrano, which is essentially better than a shell script written in Ruby. It helps you deploy things. We had about 6 servers on Amazon Web Services EC2. That was a static number. We would bump it up if we knew there was something big happening, bump it back down if we needed to. And in front of that, we had AWS's Elastic Load Balancer. So then a project came out where we wanted to actually separate out our homepage from the rest of the API. We wanted to do this so we could move faster with our homepage, have different developers working on it. And the big buzzword at the time and still today is service-oriented architecture. So version 2 of our stack was to enable service-oriented architecture, which our first plan was to separate the homepage from API. That seems really simple. We have www.bellycard.com and api.bellycard.com. But it turned out to be really complex and not simple whatsoever, because some of our mobile applications were statically written to use www.bellycard.com/API and API assets. Our email providers and all of our click links that have already been emailed to people had /EO for email open and EC for email click. Our Facebook app was configured to www.bellycard.com/Facebook/callback. So that meant that AWS Elastic Load Balancer no longer gave us the flexibility we needed to route this traffic to different applications. So Nginx came to save the day. Specifically, we could have multiple upstreams and rewrite rules to route this traffic to our different applications. A very basic example here is we define an upstream with 6 servers and then a homepage with 2 servers. We have server blocks where we listen for api.bellycard.com and route it all to the API application. We listen on www.bellycard.com and route things accordingly. This works great. It allowed our developers to move fast. Kind of our front-end people were working on one project not being blocked by our API. So we deployed a 3rd service. I believe it was for integration with Apple's Passbook. And then a 4th, we moved all their Facebook functionality out. And a 5th to deal with user events on our website. And then someone decided it was a great idea to write that in Node.js. So now we had 5 distinct services or 2 languages. They were all deployed independently without much configuration management. And we were manually editing Nginx, which I'm sure a lot of people have started with. We needed a better way to scale this process. So we did that with Chef. Just a quick show of hands. Who here is using Chef or Puppet or something like it today? Awesome. So you most likely know that Chef is a configuration management suite. It's written in Ruby, and you can write your actual configuration management in Ruby, so it's great for developers. LearnChef.com is an amazing resource for learning about Chef, and it can teach you way more about Chef than I can in 45 minutes and probably teach you it even better with great examples. I will go over some of the basics just so we're all on the same page though. The first kind of building block in Chef is a recipe. Chef uses a lot of clever names like knife as a tool and recipe, and everything's in a cookbook, which makes it kind of fun and easy to figure out and provides a great metaphor, but makes it really hard to Google for anything. So here's the most basic recipe I can think of. Install the package Nginx and start and enable the Nginx service. You can also have file resources. So for example, I want to write out to the file user share Nginx HTML index.html the content hello world. You could also build that into a templating system. So I have a couple of variables, G and W for hello and Kevin, and I can pass these variables into a template file, which is ERB, which is a Ruby templating script. So instead of just writing out the content manually, we can write a template for greeting and to who to greet. So the last kind of major building block there is a cookbook, which is a collection of recipes, files, templates, also resources, providers, and libraries, which are more complex resources, I guess. So there are tons of open source and available cookbooks at supermarket.getchef.com, including ones for Nginx, MySQL, Java, apt-yum, even managing your SSH known hosts files. Pretty much the main basic blocks of what you're trying to do in configuration management you can find a cookbook for already. So I'm going to go through a very quick Nginx example with Chef, where we're going to install Nginx, going to configure Nginx by changing a couple of variables and things in the config, use Chef to discover where our application is running, and then configure Nginx to route traffic to our application. Also, at any point, feel free to stop me. I know I'm flying through these slides if you have any questions. So in this example, the first thing we do is set some node attributes. Every node essentially has a JSON document that you can append to set values, etc. We're going to use a third-party Nginx cookbook that looks for settings in these attributes. So we're setting worker connections to a certain value, the worker arm limit, what event type we're going to use in Nginx, and even the max body size. After that, we're going to include two recipes from the Nginx cookbook. The first is Nginx repo, which will set up either an apt or yum repository depending on your operating system, and then install Nginx. You can also install Nginx from source. Packages will be faster, of course. The next thing we're going to take advantage of here is Chef's search capabilities. When you run Chef, you can either run it as an agent on the machine, or you can run it in solo mode, which essentially runs through it like a script. But when you have an agent on a machine, you can now query the Chef server for nodes and other attributes. So here we're asking Chef to give us a list of all of the nodes that have the recipe belly API attached to it. After that, we're going to template out a site file called sites enabled API. The source will be a template, which I'll show you next. And the variables we pass through are the nodes we searched for from Chef before. The last new thing here is it notifies reload service Nginx. This says whenever this template changes, I want you to reload this service. So our template file here is pretty simple. We have an upstream called API. And in ERB here, we iterate over all of the servers we've passed through as a variable, setting the server by IP address, port 8080, and we even throw a comment with the server name there, so when an operator is looking for what's going on with this service, it'll be a nice comment for them. We also define a server block to listen for API.bellycard.com and just pass all traffic to the API upstream. I'll go back to the recipe, so hopefully this makes a little more sense. The new things here, again, we're setting node attributes, including recipes from other cookbooks, searching, and doing notification of services, which is all a lot to take in. Anyone have any questions so far? Awesome. So I also want to provide a real-world example, which might be too small for you guys to read on the projector, but you can kind of just get a feel for how complicated your Chef recipes can get. This is the actually template and recipe from some of our production servers today. So now back to our stack. I told you we deployed about 5 applications, and that was going great. We now had a way to route traffic to them. So our developers just took hold of this, and today we're up to about 40 Ruby applications that are deployed using Chef onto our servers, and traffic is routed to completely dynamically using Nginx. Developers don't really have to do anything other than edit one recipe to give the name of their new service. All of this traffic is routed by Nginx and dynamically configured with Chef. We also had about 10 front-end JavaScript applications that are just static files that we deploy on S3 with a CDN in front of it with CloudFront. Index.html is served out of the S3 bucket, and the rest of the assets are over CloudFront. We also have about another 5 apps that developers just pushed to Heroku because it was a one-off thing that eventually became production and nobody was really told about it. That was separate, completely outside of our infrastructure until a beautiful day in April when the Heartbleed bug was announced. So a lot of people scrambled. Heartbleed was a bug in OpenSSL that allowed people to potentially extract your private keys. So we were able to upgrade our OpenSSL infrastructure across all of our boxes since we use Chef. As soon as a patch was available, I believe it was deployed in about 20 minutes everywhere in our entire infrastructure. However, AWS and thus Heroku took about 24 hours to patch their Elastic Load Balancers. This prompted us to actually move all of our load balancing and SSL termination into Nginx, regardless of where it was deployed, S3, Heroku. And you take a slight penalty loss for doing so, but at least at that day in April, that was worth it to us. So our version 3 of our stack went from being SOA, all the things, to SSL, all the things. So all of our traffic to bellycard.com and its subdomains passes through our load balancers. Our assets are still actually served from CloudFront on a different domain for performance, where we don't want the overhead of SSL, and also we're only in a single data center in the East Coast. So version 4, the buzzword everyone's talking about this year is Docker. Since Docker was at, I think, version 0.5, our developers were excited to start using it. And the reasons are simple. It greatly simplifies deploying applications. There's no recipes to write. You don't need to worry about how you're going to do asset compilation, or it doesn't matter if you're writing your app in Ruby and somebody else is writing their app in Python. Essentially separates the responsibility from development and operations, where your developers can worry about code, what libraries they use, even what Linux packages they install, and allows operations to worry more things about where am I going to deploy this, how am I going to capture logging from it, how do I monitor it. And once you kind of solve those problems in operations, every application, regardless of what it's written in, will already work. As a bonus of this, it also allows our developers to easily spin up dependent services on their own laptop. As I mentioned, we're up to about 55 different applications, many of which are now in Docker containers. So if you're working on, say, our new campaign service for sending out email campaigns, it also relies on the email service. So your developer machine, typically you would go and download the code, run bundle install, start it up in the background. And but actually that relies on another service, the user service, which relies on something else and something else. So actually that campaign service I mentioned relies on about 5 other services, plus MySQL, Elasticsearch, Redis, and the list goes on and on. With Docker, we can actually build those containers from the same Chef recipes that we use in production and provide our developers with containers they can download extremely quickly and get running. Thus, this speeds up deployment and development. So version 4, we went from deploying our applications using Chef to deploying them in containers. And there are tons of solutions to do this, and I'm sure there will even be more. The first is CoreOS and Fleet. CoreOS is a stripped-out Linux operating system that runs a service discovery engine on top of it called etcd. And Fleet is a way for you to define, I want this container running 5 times, and I don't want it running on the same machines as this other service. There's another called Deis that is similar to Heroku in that it's got a git push interface. There's Apache Mesos, Google's Kubernetes. Flynn is another one that's just come out recently. And we actually have kind of our own because most of these tools weren't at a place we could use them when we started this voyage. So ours is called Jockey, and it's worked out really great because our deployment process is extremely opinionated. What's great about Docker is it's essentially providing a set of common APIs for containerization. We don't have to worry about a lot of the things we would if we were just using Linux's LXC containers. We plan on open sourcing it, but as I mentioned, deploys are really opinionated, and what works for us might not work for you. Also, our deployment strategy kind of changed when we moved to Docker. Previously, we were doing zero downtime deploys by deploying a new version of the application in place. Meaning, if we had that user fax service on 4 machines, we would use Chef to pull down the new version, install it on top of itself, and then send a signal to the web server to reload. Unicorn's a great Ruby engine for doing that. However, containers are immutable. Once you have a running container, if you want to make a new build, you should make a new container. You can kind of attach to it, run extra commands, and then save it, kind of like you would in Git. But really, if you want to get the most out of Docker, your container should be completely immutable. So that means we had to figure out a new deployment strategy because we're no longer able to deploy in place. There's a few out there. BlueGreen is an interesting one. People like their colors. Where if you've got an application running on 4 machines, you bring it up on 4 new machines and have your load balancer point to the new machines. Once you're sure it's actually working the way you expect, you can tear down your blue, and your green actually becomes the blue. Amazon's got some really great tooling for doing this with AWS. There's also canary deploys, where I want to deploy one version of the new machine, monitor it, and if it goes well, if it passes metrics checks and health checks, then we can continue the deployment. And the difference with containers here is you're going to actually tear them down and spin up new ones. So you need some kind of system to track where each application is running in your infrastructure. Chef is actually starting to become a really good way to do this. There's I guess it's a cookbook that's being merged in called Chef Metal. It allows you to actually treat containers like any other resource you would in your Chef infrastructure. There's also service discovery. Zookeeper is a very popular one. It's used all over Hadoop. Etsy's got a great product called SmartStack that allows you to kind of do deployments and keep track of them in Zookeeper. I mentioned etcd, which is essentially a distributed key value store with a REST interface. This is great compared to Zookeeper, which is more of a Java client library because you can now communicate with etcd from any of your applications. A lot of those open source platform as a service things I mentioned earlier, like Deis and Flynn, and even Google's Kubernetes, use etcd. And if you're using CoreOS, it's already there for you and built in. Another one's come out is also REST-based. It's called Consul. It's released by the people from HashiCorp that make Vagrant and Packer and tons of other awesome tools. And Consul is actually what we decided to use. So here's a diagram of the very basics of Consul. And you can see there's multiple data centers. Each data center has 3 servers. And in data center 1, there are also clients. What's interesting is within your server agents, you'll elect a master. And then all of your clients are actually aware of not only all of the servers, but also all the other clients. They then use Gossip protocol to communicate with all of the other agents. It reminds me of this old I think it was an AT&T commercial where you tell 2 friends, who tell 2 friends, and tell 2 friends. And the message spreads that way throughout your entire network of nodes. This compared to etcd or Zookeeper, where you essentially just have server agents and your clients connect to them. With the Consul way of doing things, you would actually run a Consul client on pretty much every server, everywhere we're deploying Docker, everywhere we run our load balancers. So you can always talk to that API on localhost port 8500. Just like etcd, it is a distributed key value store. You can set and get keys. They'll maintain linearizability, so you can make sure they're always consistent. There are some gotchas there, but their documentation on where those problems are is phenomenal. However, unlike etcd, they treat service discovery as a first-class citizen. So instead of just key values, you can also register services. For example, API. Once you register that service, you can tell it what node it's running on. So when we deploy a container, we also tell Consul, hey, register this service API on this container, or on this host as well. On top of that, they built distributed health checks. So now you can define Nagios-style health checks right inside your service discovery platform. So when you decide to query Consul for, give me a list of everywhere that the API service is running, you can send a flag for all, or only passing, or only unhealthy. It also has multiple data center support. I mentioned you should be running that Consul client everywhere. When you start it up, you pass in a data center parameter. If you have a data center east and data center west, you can query your local Consul client without having to be data center aware, asking for an address or something. You can also pass in $DC equals west if you're in east and want to know. We actually use the data center as a boundary for our staging and production environments. So our configuration for an application in staging might say, okay, ask me where mysql.services.consul is. And whether that's actually running on a staging node or a production node, you'll get the correct value without ever having to be data center or multi-environment aware. The other thing that's great about it, and also etcd, it has long polling on its HTTP interface. This means you can query and say, give me a list of all of the services, or all the servers that are running this service. But also, I'm going to keep this connection open for 60 seconds. And if anything changes, let me know right away. That polling time can actually go up, I think, all the way up to 10 minutes. This means you can get instant notification of any changes to your infrastructure. The other thing I mentioned already is that you can build the ability to scale out your agents by having clients everywhere. This is great because you can always talk to localhost. The big question, though, is we've got this data living in this distributed service discovery platform. That's all good and well. But how do I configure Nginx from this data? Thankfully, there's a tool released literally yesterday called Consul Template, which made me change from this point on in my slides for today. It used to be called Consul HA Proxy, which was a terrible name because it wasn't actually specific to HA Proxy. Anyways, it gives you a very simple interface to build templates to subscribe to changes in services, the health checks of those services, and even just the key value store. So you can store settings like Nginx workers inside the key value store and regenerate your config when that changes. The big ability here is to generate files from templates, which sounds really similar to what we were doing with Chef before. The bigger difference here is it uses the Golang templating language as opposed to ERB, which is Ruby. Once you change a file, you can optionally call a command on the change, for example, service nginx reload. So here's an example of running Consul template at the command line. You point it to your actual Consul host, which in this case is consulprod.example.com. In a real production, I would suggest running Consul everywhere and connecting to localhost. And then you pass in a template file, which is a Golang template. In our case, we're passing in etc Consul templates API. Then you pass in what file to actually write out. So in our case, etc nginx sites enabled API. And then a command to call, so service nginx reload. The Consul template looks really similar to a slide I had before, except instead of ERB, it's Golang. So we define two upstreams here. One's called API, one's called homepage. We have a range for the service API, and there are built-in variables for grabbing the IP and port of where that service is actually running. What's great about Consul and using it this way is the convergence on service changes is fast. Previous to deploying with Docker, we had Chef running about every 5 or 10 minutes, depending on the machine, and that was fast enough for us because we were deploying in place. Now that we're building a more advanced deployment system, we need to have notification of those changes in seconds rather than minutes. And we actually get it in milliseconds, on average probably around 200 milliseconds. However, the configuration management is still needed to generate templates. We can't just replace Chef with Consul. We still need to figure out how we're going to deploy Consul and Consul template and everything. So we are actually using Chef templates to deploy our Consul templates, which seems a little convoluted. So what we first do in our recipe in Chef is we query our Consul host for a list of all of the services, and then we generate a Consul template, and we also pass in our SSL certain key locations, and reload Consul HA proxy. We also write out an HA proxy, or I'm sorry, that's an old slide. We reload console template. We also write out a config file for console template, and we pass in which console host, the source, destination, and reload command. I'm looking into adding the ability to iterate over all of the console services that exist inside of the console template as well. This is really the guts of how we're using Chef and Consul together to get instantaneous updates to our Nginx configs. Any questions about that at this point? Cool. So next I've got some pro tips, both about Chef, Consul, and just Nginx configuration in general. The first is if you're using Chef search to find where your services are running, you should look into Chef partial search. The problem with Chef search is it makes a copy of the entire node, including all of the attributes. So if you save a lot of things to your node's attributes, you're going to have to pull those over the wire while talking to your Chef server and also store them in memory. If you have hundreds or thousands of servers you're returning from a Chef search, you can easily see how you could run out of memory in your actual recipe. Partial search allows you to return only the keys you care about. So for example, we first had nodes equals search node where recipe is belly API. That search will return objects, including every single piece of information about it. Information on its disk space, RAM, CPU, all the applications that have written their own node attributes. Instead, we can use partial search where we make a new hash here called search keys and give it a list of keys we care about, in this case, only name and IP address. And then we hit the very similar API called partial search and we pass in the additional parameter. The second thing that bit us once we moved to load balancing in front of S3 and Heroku is that Nginx resolves DNS in the upstream blocks at your configuration reload. So if you are setting an upstream to s3.amazonaws.com and it changes, which it does, or anything.herokuapp.com, your load balancer won't know about the new IP address until the next reload. The way we've gotten around that is we actually do the DNS resolution in Chef and then trigger the Nginx reload when that changes, which led to a second problem of DNS order is not always the same. So make sure you also sort that result before you write it out to your template. The other issue when you start deploying tons of services is you want to avoid stale configuration. In Apache, Nginx, and lots of other services, question? Yeah.
So I think I might have misunderstood earlier. So you said something about running on Nginx to do load balancing across all your services,
Mm-hmm.
deployed in the cloud or locally.
Yep.
So in this case, the Nginx is running on AWS, or is it running in your setup?
It's all of our infrastructure is on AWS. So when we're load balancing for S3 and Heroku, which are also on US East on Amazon AWS, we have really low latency still.
So does it need the domain name always for the upstream, or could you just configure IP addresses?
If it was your own server, you'd know the IP addresses. But when you're connecting to s3.amazonaws.com, that's actually a cluster of load balancers whose IPs are always changing. So the other big issue is we need a way to clean up our stale sites config. A lot of times with Apache, Nginx, and other Unix things, common configuration pattern is to have a conf.d folder and then load everything from it. So if I deploy services A, B, and C, make service A.conf, service B.conf, service C.conf, and then decide we're actually going to get rid of service B and replace it with service D. We now have 4 configs in our Nginx configuration folders, and B no longer exists. So you might end up with conflicts in B versus D because they have the same host name or similar. So there's kind of 2 ways we've targeted doing this before. With templates, you can add a delete function, but this became kind of unwieldy really quickly. We essentially had a list of old services that we would always try and delete if they existed, and that didn't really scale out. Another thing you can do is render all of your site configs to a single file. A lot of people have referred to it as move item potency upward. So essentially, instead of having an Nginx config that loads from multiple sources, throw it all in your nginx.conf. That does make it a little unwieldy for when you're actually logging into the box, but hopefully we're getting to the point where you're not troubleshooting a config file live in production. If that's still a little too unwieldy in your Chef recipes, what we do is we have one Nginx conf, and that loads a series of different sites. But for example, one of our site config files is about 30 services. Then we have one for the Heroku one for all the S3 ones, etc. So if you render all of your site configs to a single or a small amount of files, you don't need to worry about cleaning up after yourself. Because if your service goes away from Chef's point of view, it'll just stop rendering it to the actual file. So at this point, we got about 10, 15 minutes for questions. Yeah.
Nobody else wants to, I mean, that's not Nginx, but can you talk about the console a little bit? What's your, like, how has it worked out for you so far?
Yeah, so we've loved the console. And the thing I really like about it compared to something like etcd is there's services that continue to be built on top of it. I don't have to worry about service discovery. In fact, if you have legacy applications and you deploy, let's say your MySQL servers using Consul, Consul also provides a DNS interface. So your application doesn't need to be aware of Consul. It can just query, okay, what address do I get from mysqldb.services.consul?
So will console update your DNS?
The DNS server in that case would be Consul.
Okay.
So you would configure your DNS infrastructure. If it ends in .consul, the TLD, route it to these group of servers. But yeah, it's scaled out great for us. We're running at about 3 nodes in production for server agents and about 60 clients. Haven't hit any hiccups. They just keep adding features and don't break backward compatibility, so upgrading has always been great. Yep.
Do you utilize the upstream configuration in Nginx Plus?
We don't have Nginx Plus. We've looked into it for exactly this when we started working with Consul. If we didn't need a templating system, it would be great because we could just have a script that listens to that HTTP long polling and then speaks to the Nginx API on your behalf. The only issue there is you probably also want a templating system in case Nginx were to restart. It would reload your upstream configurations right there. There's also some work other people have done in Nginx Lua to query Consul directly. I haven't seen a good implementation yet because they tend to fall into one or two kind of buckets. The first is they're querying to Consul on every HTTP request, which is slow. The second is they loaded a configuration runtime, just like, and you end up with the same problem you had with DNS. So the templating thing's best for now. I wouldn't be surprised if we see a way to do it with Nginx Lua in the future. Yep.
Just to recap, so on a very high level, so using Chef to maintain the templates for console.
Mm-hmm.
So any changes need to happen on that layer, that's taken care of. Then you have the console mode where you listen on the long pole to changes of the infrastructure.
Mm-hmm.
And if something changes, like a service goes up or a service goes down, you go ahead and rewrite on the fly the next configuration.
And then reload it. Absolutely. But there isn't, like I said, there isn't a great way built into the console to maintain those templates. And we're already deploying Nginx with Chef. Our recipes around there are hundreds, if not thousands of lines long at this point for all the other things we're doing with Nginx, including kind of logging, tracing, and some OAuth stuff. So I don't see us moving away from Chef in our infrastructure and replacing it. But it's a great augment and good way to kind of get that rapid notification. Yeah.
I was kind of curious about what overhead you get with Chef infrastructure.
Mm-hmm.
Pretty heavy duty for you guys to have Chef.
Because most of our machines are doing kind of a single task, our actual Chef overhead is pretty low. RAM usage is low while it's sitting idle. It actually sits in a timer and can fork off. Other people also run it in a cron if they don't care about how fast it converges. We see a little bump in CPU in some of our kind of heavier recipes, but nothing we can't just deploy another server to fix. Yeah.
I'm just curious, when you use Chef to deploy your Amazon instances,
Mm-hmm.
do you incorporate the CloudFormation, for example, so that if you want to remove, easy to intend to remove all your
Yep, so we're not using CloudFormation yet. It's on our radar. The kind of one change we've done there is we've been starting to utilize a lot more auto-scale groups. So the way that'll work is we'll have, when an instance comes up, it'll have a user data that contains its chef run list. So a new machine will come up into a cluster. It has a key already based on its image, so it's able to talk to our chef server, register itself, and pull down the cookbooks it needs. That kind of solves most of the CloudFormation stuff for us because we're not using a lot of the other AWS tools that would kind of go hand in hand with that.
So when you need to destroy a server, you can use Chef to clean up all the server.
So if a server goes away in an autoscale group, you can use Amazon SNS to get a notification of that. So we have a very simple service that listens for those notifications and then cleans up the chef server. Yeah.
Do you know OutSource?
What was that?
OutSource from Amazon?
I'm sorry, I couldn't hear you.
OutSource.
Oh,
That service.
we haven't used it. We've been using the hosted Chef since the beginning, and it's worked out great for us. I'm about 50-50 on knowing this right, but I believe if you're using OpsWorks, it's more of Chef Solo, where you're kind of using it just for provisioning. We still run Chef Agent on almost all of our machines. And then we use those same Chef recipes to generate Docker containers for development. So. Any other questions? All right. Well, thank you all for coming. I've got the plug of yes, Belly is hiring for all engineering roles. Slides will be posted. That's a typo. I'll tweet them out. I'm at Kevin Reedy. They'll also be posted on tech.bellycard.com, which is our tech blog. If you have any questions about this whatsoever, I'll be around all day, and feel free to always hit me up on Twitter or email. I'm always happy to help. So thank you, guys.